But with question 2, they're asking us to find the modulus, right, of A and the modulus of B. Now the modulus is the size, right, the actual size of it. Another name for size is the magnitude, right? How big is it? What size has it got, right? Now to get the size of it, right, with A, I can actually show you the process, okay, and why we use this process. Because if we actually draw this out on a y and x axis, x and y axis, okay, or an I and j in this case, of course, yeah, because I would represent the vector, unit vector along the x axis, so your i's here, yeah, and of course then your j's will be along the y-axis. So we've got your 3i plus 6j, so we're going to go across to 3 and up to 6, so it'll be about there somewhere, right, roughly. It doesn't matter about the scale here, getting that right, but basically I've gone across 3, haven't I? Yeah, gone across 3 to be 3i, and then I've gone up 6 here, which I can sort of squeeze in on my scale there, yeah. So that there is vector A, okay, so I'll underline it. And to get to the point here of vector A, okay, go along that vector there from the origin, I've got to go across 3, up 6. So to get the size of that, right, okay, what you need to appreciate is we've got a right angle triangle, okay. The distance across there, we know, of course, is 3, yeah? And we know the distance here is 6. So if you think about Pythagoras, you'd square that side, wouldn't you? And square that side, and that would equal the square of this side, yeah? And then to actually work what that is then, you take the square over. So in that case, to get the size of A, you'd square that, as I said, you'd square the 6, okay, add them, and then of course that would be the A squared, and then we take the square over and we square root. So you're simply using Pythagoras' theorem, okay? That's what's going on there. And you just get your calculator and 3 squared plus 6 squared, and we put our answer, and that comes out to be 3 root 5, okay? Same with B. Now B is in 3 dimensions, okay, and a similar process occurs. I'm not really good at drawing 3D pictures, okay, so I'm not going to do it. I'm not going to do a 3D diagram, but actually Pythagoras theorem works in an identical way there, and what you'll find is, right, is that you do the same thing. You square, okay, all of the different dimensions. So the 2 here you square, okay, and then you add then, just like we added the sides in the 2 dimensions, yeah, okay, so we did the 2 smaller sides added together, yeah, once you square them, so 3 squared, add the 6 squared, you do the same here, you add that squared plus this squared. Now I know it's a minus, but that minus will disappear, won't it, when you square, right? Okay, so don't worry about the minus as such. Put it in a bracket though, yeah? And then we add, then minus 7 squared. So, get my calculator. 2 squared plus minus 3 squared plus minus 7 squared, okay? So we get the answer out to be root 62. Okay, and that's the size of that vector. Now I could have simply typed in 2 squared plus 3 squared plus 7 squared. I didn't need to put the minuses in those brackets as I did. You'd get the same answer, because of course when you square a minus, it's a positive. But if you do put the minus in, as I said, make sure you put in a bracket so that it actually squares it, right? Positive. And there's the size of the vector.